Okay. So here it refers to a figure, all right? So the figure shows an adiabatic cylindrical tube of volume V naught that is divided in two parts by a frictionless adiabatic separator, all right? So this separator is, is adiabatic and it can move freely and because it has no friction, okay? Initially, the separator is kept in the middle. So if separator is kept in the middle, here the volume is V naught by 2, and here also volume is V naught by 2. Okay. So an ideal gas at pressure P1 and T1 is injected into the left part, and another ideal gas at pressure P2 and temperature T2 is injected on the right part. Cp by Cv is also given to you, okay, which is same for both the gases. The separator is slid slowly and released at a position where it can stay in equilibrium. Okay, so the separator is moved slowly and it is released where it can be in equilibrium. You need to find out the volumes of the two parts when it stays in the equilibrium. Okay, that is part A of the question. Now, if you look at the separator, which is free to move, okay, so let's draw its free body diagram. So from this side, it will experience a pressure, okay, and from that side also it will experience a pressure, all right. So the force due to a pressure from this side will be equal to, let us say P1 dash is the pressure. So P1 dash into A from left side and P2A dash into A from the right hand side. Okay, so these are the two forces acting on the piston. So area of cross section is same both sides. So if P1 dash is more than P2 dash, what will happen? The separator will move towards the right and it will move towards the left if P1 dash is less than P2 dash. Okay, so if it remains in equilibrium, which is written over here, that it stays in equilibrium, it means that pressure on both the sides of the vessel or a cylindrical tube will become equal. Okay, so initial pressure, temperature and volume is given and the separator is moved to a position where the pressure on both sides become equal. All right, so we need to find out that pressure. Fine. So you can notice few keywords over here. The cylinder is adiabatic, okay, and separator is also adiabatic. So whatever happens on the left side, this follows adiabatic process, and on the right hand side also there is adiabatic process that is going on. Okay, so I can write down adiabatic process equations. Fine. So if you take, let us say I take P1 into V naught by 2 raised to power gamma. Okay. So pressure into volume ratio power gamma will be a constant if it is adiabatic process, right? So P1 into V naught by 2 raised to power gamma should be equal to what? Let's say the final equilibrium pressure is P. So that into V1 raised to power gamma. Fine. So this is for the left portion. Okay, so for the right portion, you can write down P2 V naught by 2 raised to power gamma is equal to what? Again, the pressure will be same, but the volume will be what? V naught minus V raised to power gamma. Right? So whatever is the leftover volume, total volume is V naught. So if V1 is the volume of the left portion, V naught minus V1 will be the volume of the right portion. Fine. So this equation is for the right portion of the cylinder. Okay. So if I use these two equations, let's call it equation number 1 and equation number 2, I can divide them and then I can find out the volume. So if I divide it, I will get what? P1 divided by P2. This I will get as V1 divided by V naught minus V1 raised to power gamma. Fine. So V1 divided by V naught minus V1 will be equal to P1 raised to power 1 by gamma divided by P2 raised to power 1 by gamma. Okay. So this will give you V1 divided by V naught equals to P1 raised to power 1 by gamma divided by this plus that. Okay. So V1 will be equal to what? V1 will be this multiplied by V naught. Okay. So you can see that this kind of expression you will be getting for V1. Okay. So V2 will be what? V2 will be V naught minus V1. Okay. So using equation 3, I'll get V1. And once I use it in equation number 4, I'll get the value of V2. Okay. Then what is asked is heat given to the gas in the left part. Fine. Now left part, it is clearly written, it cannot exchange heat from the surrounding because the cylindrical tube is adiabatic and even the separator is adiabatic. So it cannot exchange heat from anywhere. So there is no question of giving heat to the left portion of the gas. So the heat exchange will be 0. All right. Now part C asked common pressure of the gases. Now once you get V1, okay, you can substitute in equation number 1 and you will get the value of P. Okay, so let's try to get it quickly. So P1 V naught by 2 raised to power gamma is equal to P into this entire expression raised to power gamma into V naught raised to power gamma. Fine. Now you can see here that you can get rid of P1 raised to power 1 by gamma raised to power gamma is P1 only. So this thing will get cancelled out from here and V0 raised to power gamma is gone from there. All right. So you will get P as equal to P1 1 by gamma plus P2 raised to power 1 by gamma divided by 2 this raised to power gamma. Okay, so like this you can do part C of the question. Okay, so I hope you have learned something today, and in case you have any queries from your side, feel free to get in touch with us. Okay, thank you.